Hi there. In this video, we'll learn about comparing between two projects that are mutually exclusive and their scale is different. One of them is large scale and the other is small scale alternative. Let us consider this example in which we are considering that there is a forest in which we can set up a simple setup that deals with cutting and exporting the timber. So this is a smaller version of this project of exporting the timber. Other option is that is at a larger scale. It is about setting up a sawmill in which definitely there are machines and there is a greater capacity of cutting the timber and putting it in certain shapes and modifying it, refining it as per the requirements of the project. So there is a larger version of the project and there is a smaller version of the project. Both use labor and capital, and the thing is that the scale of this project is greater. So which one of these should we choose is the question. And when we calculate the net present value of the larger project, it is greater than that of the smaller project or the smaller version. But its economic rate of return, that is economic IRR, it is lower, and its net benefit investment ratio is also smaller. So that's the situation in which we are double-minded, because one of the measure guides us for the larger scale alternative and the remaining discounted measures of project worth, they guide for the smaller scale of the project. For this we have to do some calculations. Let us see. Initially we start with the small scale alternative, in which we have the usual years, and it is of 20 years, and we have the capital cost, we have operation and maintenance costs, and we have the benefits. We can calculate the net benefits of the small scale alternative by taking the difference of the benefits and these two components of the costs. Then we can calculate the discounted benefits and discounted costs separately in these two columns, and then we can take their difference, that is the discounted net benefits, which will give us the net present value of the small scale project. So this will be the net present value of the small scale project, which is a positive one. So it means that in itself the small scale project is desirable. The IRR is also there, it is 26.699%. BCR is also there, which is 1.921, and NKR it is 1.989. So these are the findings from this small scale alternative. Let's talk about the large scale alternative, that how it works. Again we have same column headers, but this time we are dealing with the large scale alternative. Now we do the calculations here. You can pause the video and see if the calculations are correct. This would be the final column, discounted net benefits column. If we sum them up, we will get the NPV, which is 683.48. So this is greater than the NPV of the small scale project, which was 441, but this is 683. So this NPV criterion guides that we should undertake the large scale alternative, whereas the IRR, it is smaller. It was 26, but approximately, and this is 16. So there is a evident difference, and we can say that small scale alternative is desirable as per the IRR criterion. And these are the ratios of BCR and NK, 1.9 approximately, and here these are smaller. It means that they are also giving the same kind of interpretation as given by IRR, that small scale alternative is superior and large scale alternative is superior as per the NPV criterion. This is where we have to come up with some other alternative, because right now there is a confusion between and among the various discounted measures of project worth. For this, what we do is we combine the net benefits of the small scale and the large scale project in one column, in one table. We know that the discounting factor is 12%. We are also given the OCC, which is the opportunity cost of capital. It is also 12%. Now we will calculate the difference of the two net benefits. Here we are, delta NB, and we can see that it is calculated by taking the difference. That is, we write NBLS primarily minus NBSS, that is net benefits of the large scale project minus net benefits of the small scale project. These will be the values, and finally we can sum them to get the NPV. These are the NPVs that we have already calculated. This is the NPV that we can calculate by taking the difference of the two. Now we have crossover discount rate. What I have done is that I have introduced a few additional columns to explain the situation here. I have calculated the discounted versions of the net benefits of the small scale project, discounted version of the net benefits of the large scale project, and discounted version of the net benefits of difference of the two net benefits, that is net benefits of the small scale minus net benefits of the large scale minus net benefits of the small scale project. We will place the large scale project before the small scale project because its values are greater than that of the small scale project. Now the net benefits, the difference of them, if we take the discounted values, it will give us this column. So the NPVs now, they are making more sense because I have given the discounted versions as well. So this is the NPV of the small scale, NPV of large scale, and the NPV of the difference of the two stream of the net benefits. Now when we have such a situation, then we can find out the crossover discount rate to find out which one of the scale of the project is suitable. The answer of the crossover discount rate is already mentioned. Let us see that how the NPV profile can help us to develop all of this. So NPV profile with the difference of 1% discount rate, 0, 1%, 2%, 3%, and so on. So we have gone to up to 17%, and NPV of small scale and NPV of large scale projects are calculated, but most importantly the NPV of the difference of the two projects, it has been calculated. So NPV of the difference, it's positive but declines as we increase the discount rate, and which is quite natural that an increase in the discount rate decreases the net benefits. And then we have the point where the final positive NPV appears of the difference of the two, and this is the first one of the negative of the value of the NPV, which is the difference of the two scales of the project. So we can understand that between 13 and 14% the crossover discount rate would exist, at which the NPVs, they turn their values in terms of in their signs. And the interpretation that we have is that when the NPV of the differential of the NPV is positive, then we prefer large scale, but when it turns negative, we prefer the small scale project. It's very intuitive because the difference is of large scale and small scale, so it is actually giving us the component which is greater of the larger scale project as compared to the small scale project. So it is the additional net benefit that we are talking about, and if it is positive, it means that the large scale project is desirable, but if it is negative, then the small scale alternative would be desirable, which is the other possibility. But just to remind you, it is not the net benefit, it is the NPV. So we are talking about the background of this NPV, that this column, that is the net benefits, we are talking about this column, on the basis of which one of the NPVs will be calculated, and we have mentioned that NPV here, various possibilities of those NPVs. Now this is that NPV that we calculated over there at 12%. But we can clearly see that the discount rate will be between 13 and 14%. You can go back to the topic of crossover discount rate to remember about the interpretation and how this change in the interpretation happens. Now the findings summarized in a table. This is where the discount rate is mentioned. It was 12%, and when we resorted to NPV, the small scale project had a smaller NPV and the large scale project had a greater NPV. So NPV was suggesting that large scale project is desirable. But when we resort to IRR, the small scale project has a greater IRR, and that means that a small scale project is desirable. So this is the controversy for which we resorted to the crossover discount rate. This is another calculation, NPV of the differential of the net benefits. At discount rate it was equal to this. So all these values are self-evident. These are the calculations on the discount rates, that is given discount rate, which was 12%. Now we come to the crossover discount rate, as we can find this out by using the interpolation. Here it is not done, but you can pause the video and recall the formula of interpolation and use it in order to find the crossover discount rate, and you will need these three values: discount rate lower, and NPV at lower discount rate, discount rate higher, and NPV at higher discount rate. And after using this, we can find the NPV at crossover discount rate of the small scale project and the large scale project, and they should be equal to each other, as the diagram mentioned that this is the crossover or the intersection of the two NPV curves, that is of the small scale and of the large scale projects. So we have 347 and 347 again, so they are equal. This shows that the crossover discount rate is correct, and NPV of the differential net benefit stream at crossover discount rate should be 0, because the net benefits are the same at this point, so we should expect that the NPV will be equal to 0. So large scale project is to be compared with the small scale project, and we were also given the opportunity cost of capital, which was 12%, and it had to be compared with the crossover discount rate. That is, in simple words, the additional net benefits of going for large scale benefits, the internal rate of return or the rate of return of it will be known as the crossover discount rate. So it is 13.78%. It means that the alternative will give us 12% if we use the capital in the alternative, whereas if we undertake the large scale project, it is going to give us 13.78% return on the additional net benefits as compared to the small scale project, because we take the difference of the two, large scale minus small scale. So this means that if we are going to undertake extra investment on large scale project, then it is going to be justified. So we can go for the large scale project, and it is indeed beneficial. Here we can also see the superiority of NPV over other measures of discounted version, because we remember that NPV was greater for large scale and it was smaller for the small scale project. And here this crossover discount rate is also identifying that the large scale project is desirable, and we remember that IRR was not giving us the same recommendation. It was in favor of the small scale project. So you see that crossover discount rate is also verifying the superiority of NPV, even in this case where the two projects are to be compared for their scale of production. So this was the finding, this was the conclusion, this was the comparison of all the results, and this was the NPV profile, and we were able to find out the crossover discount rate by making this table. And then we had the crossover discount rate. We also had the NPVs of the small scale projects, large scale project, and more specifically the difference of the two, that is differential net benefits. And this was a summary of the DMPWs of the large scale project. This was its stream, and this was the summary of the DMPWs of the small scale project. And this is the thing, that is the small scale alternative. So this is how we can compare the two alternatives, where one is a smaller scale version and the other is the larger scale version. Thank you.